Okay, so hello and welcome back to this online machine learning course. So as you know, in the last class we discussed about dividing machine learning into two categories, probably in the supervised machine learning, let me change the color, into supervised machine learning and the unsupervised machine learning. Now, these classifications of supervised and unsupervised machine learning were based on whether our y values were present or not. Like in supervised machine learning, we had the y values. In unsupervised machine learning, we did not have any y values, right? Now we can further classify supervised machine learning into two such categories, and these mainly are regression and classification. Now the basis on which these are classified is on the nature of the output labels, right? It is on the basis of the nature of the output labels. Let me show you what exactly are these. So in supervised machine, I hope you know about this part. Now the difference arises, so the goal are, because you know our goal and objective is to find a mapping or relation between the input variables and the output variables, right? And so the difference arises whether our output label is a continuous or a discrete values. For example, I want to predict my values for gold. I'm sorry for the rough graph in the x's and the y's, right? Now this y, if it is a continuous variable or a discrete variable, I get different algorithms, or I use different versions of supervised machine learning for this. And so the ones which are regression, now let's get to the regression part. So this arises when the output part or the y values are continuous, right? So regression consists of continuous y value. I mean, let's look at this diagram figure over here, and let me for the time being assume that these are the y values and these are the x's, and so let's assume that this x is the time in year and this y's are the price or the housing price. Okay, now we got a very large data set and we are plotting each of these y plots which you can see out here. Each of these y points you're seeing out here is actually predicting or matching that for 1.5 you are getting a value of perhaps 5,000. If you actually put it straight, you would be getting a near better value for that. So perhaps 5,000 is a clear picture for this. And you map it out for several data and you actually plot a graph out of this. Now we assume that this y is actually a continuous variable ranging between 0 to infinity, and actually in our graph we are actually showing till 15,000 over here. We are showing 10,000 over here, but the values in between 10,000 and 15,000, there exist values such as, for example, 12,000 may exist over here. So 12,000 does exist in between this graph, and so it is a continuous graph between 0 to infinity. And so regression is when this y that we are dealing over here is a continuous variable. Now let's get to classification problems. So in these problems we deal when the output labels are not continuous but discrete. Okay, now let's for example, I've given you 2 red balls and 4 green balls. Now I want to segregate these balls into 2 different boxes, wherein the first box contains all the red balls and the second box contains all the blue balls. Now you place these balls and you segregate these objects into respective boxes. But the point is that there is no separate box. Like for example, if I got a brown box, if I got one brown ball, suppose I got one brown ball I cannot put this brown ball in either of red or blue or somewhere in between them. These are discrete containers or individual containers, right? So let me take this example take this example. Okay, for the time being, take this as x and x1 and x2. Like these two are features, and our a and b, which we are seeing over here, are y values. Like for example, in this case, for example, this is the red one. These are the red ones, and these are the blue ones. And we want to classify. Now, this graph may give an intuition that it is an unsupervised machine learning because we are not having any labels. In fact, we are having labels over here, so it is indeed a supervised machine learning problem because we are having red and blue segregated. So, now, for example, if somehow I find out that I classify these balls as red and these balls as blue, and actually I put these balls into different containers, I have actually performed my function or my job of classifying these two data points or these data points and segregating them successfully into these containers. And so that is what we deal in classification. And so that's it. So thank you for watching.